We have seen what happens when we take the limit as x goes to positive and negative infinity of a polynomial function. So when you have a polynomial function, if x is going to positive or negative infinity, y is going to positive or negative infinity. This will not be the case for rational functions. So first we're going to take a look at limits going to infinity, at infinity, and then in the next video we'll take a look at what happens when y is going to positive or negative infinity. So if f of x is a rational function, which is a polynomial divided by another polynomial, x is approaching positive or negative infinity, and y is approaching a real number, so that wouldn't be positive or negative infinity, then f of x has a horizontal asymptote at y equals the value of the limit. So you have a rational function, you're taking the limit as x goes to positive or negative infinity, and y is approaching a number. So as x is getting really large or really small, the y's are approaching a certain value. So similarly to polynomials, when x approaches negative or positive infinity, we use the leading term. So if you're trying to find the values algebraically, we're going to use the leading term. Now here's a visual of what that looks like when you have a horizontal asymptote. So if I zoom in a little bit here we have the limit as x goes to positive infinity, right? Because remember, like, this is when x is going to infinity. But your y's are approaching a number. So the line here, if you're driving on the line, the y's are getting closer and closer to the number L. So the limit is L. And if we take a look over here, this is going right to negative infinity. This is your x. So you're driving here on this graph. And the y's are getting closer and closer to M. So in this graph, you actually have two horizontal asymptotes. You have y equals L and y equals M. But normally when you have irrational functions, this will not be the case. You'll have one horizontal asymptote, which we'll see later on. So we have this very important limit called the reciprocal limits. And what it tells you, because we're going to be using this to help us algebraically, is that if p is a positive number, so your power is positive, and your x is at the bottom. So you have a number k over x to the p. If your x is going to positive or negative infinity, your limit is going to 0. So I can use an example. For example, say I was taking the limit as x goes to infinity of 3 over x. And we want to find out what this is. So what happens is, if I start off, like, say if I do like 3 over 10, 3 over 100, 3 over 10,000, and if I keep doing this, what's happening is that the fraction is getting smaller and smaller and smaller, so the fraction is going to 0. It's never going to hit 0, but it's approaching 0, which, remember, when we're dealing with limits, that's what we care about. We care about what is approaching. So the limit will be 0. This will also be true if there was a negative in front of the infinity, all right? Because you would have negative 3/10, negative 3 over 100, negative 3 over 10,000, and that would still be going to 0. It's just that instead of approaching 0 from the right, it would be approaching 0 from the left, from the negatives, all right? But it would still be approaching 0. So let's take a look. We're going to have three different scenarios that can happen, and each of these questions is going to go through one of the scenarios. So first of all, let's remember to take a look at our problem. It's the limit as x goes to positive or negative infinity, and it is a rational function. It's very important that you recognize that in number 1, in number 2, and in number 3, all of these are rational functions. They are a polynomial divided by another polynomial. So because it's a rational function, and because we're taking the limit as x goes to positive or negative infinity, we are going to look at the leading term, but of the top and the bottom. So in a polynomial, you only have one leading term. So here, because I have a top and a bottom, I have a leading term in the top and a leading term in the bottom. So for number 1, my leading term is 2x squared, and in the bottom, it's 3x squared. So I'm going to rewrite my limit. I still need my limit symbol because I'm not evaluating it yet. I'm just taking the leading term. And I'm going to do this actually for all 3 problems here. Let's take a look at all 3 at a time. So in the next one, the leading term in the top is 3x cubed, and then the bottom is x to the 4th. So I have that this is equal to the limit as x goes to negative infinity of 3x cubed over x to the 4th. And in the last one, well, in the last one I have a little issue. Well, not in the top. In the top it's easy. It's 7x to the 6th. But in the bottom, we saw this in the last video, is that I can't take the leading term in factored form, so I need to FOIL this out. So this is x to the fourth plus x squared. And now I can see that my leading term is x to the fourth. So this is equal to the limit as x goes to negative infinity of 7x to the 6 over x to the fourth. Okay, so I started the problem exactly the same for all three. The next step is also exactly the same, which is to simplify the fraction that you have of the leading terms. So in the first one, I have an x squared in the top and an x squared in the bottom. So the x squares are going to cancel out. And I'm going to be left with still the limit. I haven't taken the limit yet as x goes to infinity of 2/3. As to the next one, I have a x cubed in the top and an x to the fourth in the bottom. So 3 here will cancel with 3 in the bottom. So I'll be left with 1. So I'm going to have the limit as x goes to negative infinity of 3 over x. And last but not least, in the last one, I have 6 in the top and 4 in the bottom. So 4 of these will cancel with 4 in the top, which will leave me with a 2. So I'm going to have the limit as x goes to negative infinity of 7x squared. Now this is when it changes, okay? And this is when your 3 scenarios happen. So the 3 scenarios that just happened is scenario 1, you're left with no more x's. Scenario 2, you're left with x's in the bottom, but no more in the top. And scenario 3 is you're left with x's in the top, but not in the bottom. Because remember here, there's really like a 1 that we don't write. So scenario 1 is the limit of a constant is always a constant, right? So we learned that previously, that if you take the limit as x approaches a number or positive or negative infinity of k, it's always going to equal to k. Because what happens is that this 2/3, when we graph it, it's a horizontal line, y equals to 2/3. So when x is going to infinity, the y is still going to be 2/3. The y is always 2/3, so it doesn't matter what the x is doing, the y is 2/3. So the limit is 2/3. In the next one, we use the limit we just learned at the top here, which actually I wrote 3 over x and I forgot that it was going to be 3 over x, so it worked out well for us. So we just saw that if you have the limit as x goes to positive or negative infinity of a number over x, that is going to go to 0. Because the fraction is going to get smaller and smaller. And the last one, you need to use your previous knowledge. We're taking the limit as x goes to negative infinity of 7x squared, but 7x squared is a polynomial. So you're going to put in a negative x into the squared, so that's going to give us a positive. The 7 is a positive, so this is going to go to positive infinity. So scenario 1, no more x's. Scenario 2, x is in the bottom. Scenario 3, x is in the top. So those are the only 3 options that can happen when you're taking the limit as x goes to positive or negative infinity of a rational function. And again here, please be careful with your notation. Pay attention to your limit notation. As you can see, I didn't drop the limit notation until the very end when I evaluated the limit here. And then the last thing is, let's go back to the horizontal asymptote. Now, it doesn't ask for the horizontal asymptote. So this is just a side note. We have our answer. Our answers are 2/3, 0, and infinity. But as a side note, number 1 and number 2, the graph of f of x, the graph of those functions inside the limit would have a horizontal asymptote. So number 1 would have a horizontal asymptote at y equals to 2/3. And number 2 would have a horizontal asymptote at y equals 0. And number 3 would have no horizontal asymptote because infinity can't be a horizontal asymptote. So this is just as a side note. I'll write it on the side. This would have a horizontal asymptote at y equals to 2/3. This would have a horizontal asymptote at y equals 0. And this would have no horizontal asymptote. But keep in mind, that's not the answer to your limit. The answers to your limit are 2/3, 0, and infinity. If it then asked you if it had a horizontal asymptote, you would write it as y equals.